Okay, so let's put what we learned in practice. All right. So again, if I want to, I'm going to handle these one at a time for a couple of these, and then I'll put it all together. So first of all, what I want to try to do is, let's say I want to try to prove symmetry about the y-axis for this first one. Right. Well, what we just learned, right, to be symmetric about the y-axis, the idea, the test, if you would, right, is to basically, if I'm symmetrical by the y-axis, we're going to go from an ordered pair xy to an ordered pair negative xy. And so I'm going to start that journey by putting that into the function. So if I go through here and I replace all my x's with negative x, right? Oops, that shouldn't be there. So I just went through, y is still going to remain the same, right? Y is y. But in order to be symmetrical about the y-axis, if I replace my x with negative x, what should happen is we should come back to the original equation. If we can, that means that both this point and this point are actually on the graph, right? For all x and y. That's what has to happen. All x and y that has to occur. Well, negative x squared, it doesn't really matter if it's positive or negative. That's the same as just x squared. However, here, right, negative, we have a 2 times a negative x and a minus. That's actually going to give us 2x plus 2x and then plus 3. So if we go compare what I now have to what I originally started with, we can see that they're not equal. So I've just proven that this is not symmetric, right, about the y-axis. That is basically the proof that I did. I tried, again, if they are symmetric, this data point and this data point to satisfy the same equation. Well, this is going to satisfy this type of equation, where that satisfies that type of equation. They're not the same, we're not symmetric. So that's basically what you do. And again, I'm going to do one at a time as we go along. So the x-axis, right? What happens when we're trying to find something symmetric with the x-axis? Well, this time, right, we found that if xy, right, satisfies this guy, then x negative y has to pretty much satisfy the next guy. All right, that's what's going to happen in order to be symmetric about the x-axis. So if I go and make the replacement, right, we have that and that, right? And so I got to try to get back to the original one. So how about I take negative 1 and multiply it to both sides. So again, I said there's always some math. This is going to get us back to y, which is a good thing, right? I want to get back to y. But on the other side, we have negative x to the fourth plus x squared, right, when I distribute that minus 1. And if you take a look at what we have here and compare it to the original one, right, they are not equal. So I've just proved that we are not symmetric with the x-axis. All right, so unfortunately, no go. All right, and then to do the last one here, right, let's just say we are symmetric. How about, I'm going to keep with these guys going on, right? Let's try to prove if we're symmetric with the the x-axis for this one. Just one more test, right? So again, we're going to start with xy, right? That's what satisfies that one, right? To be symmetric about the x-axis, that better satisfy it as well. And so when we go plug this in, we got x plus the absolute value of negative y equals 5. What do we know about the absolute value of y? Well, it doesn't matter if I'm positive or negative, they're the same value, right? Absolute value of negative y is the same thing as the absolute value of yy. So there's our math. Take a look at what we have here and compare it to where we started with, and they are equal. So now what I've done is I proved that yes, we are symmetric about the x-axis. So that's what I gave you showed you two ways where the test didn't work, so symmetry was not proven, and then we had one where the symmetry actually is proven. And so that's basically how you do that. So there are some things one at a time. How about I do all three of them with the next three? We'll do all tests. So first off, for this guy, let me kind of square some things off here. What do we do with the origin? Well, for the origin, right, we're going from xy, and we're going to replace it with a double negative, right? To be symmetric about the origin, both have to be negative. So this guy already solves that equation. Does this guy also solve the same equation? So when I plug that into the equation that we have, right, we know that if I square a negative, that's the exact same thing as squaring a positive. If I square a negative, it's the same thing as a positive, and we get 9. So there's the math. I'm right back to the original equation. So the answer is yes. We are symmetric about the origin because it passed the test. What about the x-axis? Are we symmetric about the x? How about I do y since I've done x a couple times? What about the y-axis? Well, we're going to replace x comma y, right, with negative x. Oops. Make sure I did this right here, yeah. With the y-axis, with negative x comma y. All right, and so when I do that replacement, we have negative x squared plus y squared equals 9. Again, we're back to the idea that squaring a negative is the same thing. So I got the same thing, so the answer is yes. All right, so this is also this equation symmetric about the y-axis. What about symmetry about the x-axis? Well, the test begins, right? We already know that x comma y is on the graph, so we're trying to figure out, right, what about x comma negative y? So if I place that into the equation, right, we get negative y squared equals 9. Squaring a negative is the same thing as squaring a positive, get the same thing back. So the answer is yes. We're symmetric about the x-axis. I think in another earlier video I shared with you guys that this is actually a circle, right? And you can kind of see once I draw that circle, we can visually see what I basically proved algebraically. We're symmetric about the origin, right? If I rotate this around 180 degrees, I'm basically rotating the circle around 180, getting the same circle. It's mirror image right across the y-axis, so it's symmetric about the y-axis, and it's a mirror image across the x-axis, so it's symmetric about that as well. All right, so there's the test, right, individually, and then all together for one. We're already a little over 7 minutes into this, so how about I do the next two, right, in another video, all right? But again, to summarize real quick, symmetry about the y-axis, we're just basically testing, does negative x comma y satisfy the same equation? For symmetry about the x-axis, we're trying to figure out, does x negative y satisfy the same equation? And for symmetry around the origin, we're trying to prove, does negative x negative y satisfy the same equation? It's all about solution points. Do I satisfy, am I a solution to the equation? If I am, then yes, we're symmetric. If I'm not, then no, we're not. Right? So we'll do the next two in another video.